Welcome to this session, and in this session we are going to see about the taper turning operation and the contouring like fillet operations. See, this operation is similar to the step turning operations which we have explained in my previous session. Let me show you how the workpiece looks like. So this is the workpiece, and let me tell how the coordinate points in this workpiece. You see, this is having a diameter of 10, diameter of 50, diameter of 70, diameter of 100, and there is a taper for a length of 60, and there is a fillet for a length of 10, and there is a step turning for a length of 50, and again plain turning for a length of 40. So we have to find out the coordinate values at all these points. As I explained before in this session, we have to take the value of diameter for the value of x at all these points, and so do here also. And we will be taking 10, 0 at this place. X is 10, z is 0, and here x is 50, z is minus 60 because it is 60 here in negative z direction. And at this place x is 70, z is also minus 70. At this place x is again 70, z is minus 120. At this place x is 100, z is minus 120. And at this place x is again 100, but z is minus 160 because 60 plus 70, 120, 160. So we have found the coordinate values. Now we have to see how the tool is moving. Tool is coming from somewhere here from the machine 0 point, and it comes to near the workpiece surface. Okay, this is a block of before machining the block diameter is 100, so better to keep the tool little away from 100. We can take x 101, means 1 mm away from the outer contour of the workpiece. Okay, so from machine 0 we will move till here, but it should not touch the face of the workpiece also, so we will keep z value some positive value, means z1 or 2 like this. So we can take initially for safety from machine 0 point G28 we bring it to x 101 and z plus 2. I have given you here x 101, z plus 2. After that, from here we move to point number 1, then point number 2, point number 3, point number 4, point number 5, point number 6. This is the tool path. Okay, and how it moves from point number 1 to 2 is linear cut, so G01, but 2 to 3 is circular interpolation. It may be G02 or G03, but in this case it is in counterclockwise direction. From this point to this point it moves in counterclockwise direction, so here we will be using G03, again G01, again G01, again G01. So tool path we can define using the coordinate values. And since this is a turning operation, here also we have to tell this is a turning cycle, so we will be using the command called G71. G71 means it is a turning cycle. When you use G71, it should follow with the depth of cut U value. U is 1. You can give 2 also, you can give 3 also, but here let us take it as 1. Small depth of cut is always good. And R value, R means retract value. Retract means after depth of cut come out, again go back to initial position, again depth of cut, cut the material, come out. This coming out means relieving from the workpiece surface is called as retract value. That value also we keep it as R1. You can keep R2 also, R3 also, but in this program we will take it as R1 and U1. Okay, so this is about defining the turning cycle G71. After defining the cycle, you should tell the block number from where till where the turning cycle continues, means from which block number to which block number the turning cycle continues. So from block number is shown by P value, that is G71 P some value, and to block number it is shown by Q value, that is Q some value. That is shown here. You see, after giving the turning cycle G71 U1 R1, we are going to give G71 P600. That means from the 600 block the turning cycle starts till Q1100, means till this 1100 block number 1100, the turning cycle continues. Okay, and u is 0, w is 0. This is representing the axis in x direction, this is the axis in y direction. So we take it as 0 reference axis, okay, in x and y direction, x and z direction, sorry, and feed value is 0.5. So this we are going to define, and this is how we are going to do the program. Now let us see the program block by block. You see, the first one is the program number 203, and next is about the block number, first block, that is n100, go to home position, and then fixing the maximum spindle speed G50, take a SS 3000, and then change the tool M06, T03, T03 is the turning tool, and then tell absolute programming G00, it is not cutting, rapid travel, go to the point number X101, Z2. From where? From the machine 0 point, go to the point X101, Z2. Means if machine 0 is somewhere here, from here it moves to X101, Z2. Okay, and then from here we will tell this is a turning cycle. So G71, U1, R1, turning cycle. Then we tell what is the block number for beginning of turning cycle, end of turning cycle. So again G71, P600 till Q1100, P600 till Q1100, and U0, W0, F this much. After this we will keep giving the turning cycle, you know, you will keep defining the point number 1, point 2, point 3, etc. So the first point is from here we are moving to first point. So first point is 10, 0. 0 means it is touching the workpiece. Since it is touching the workpiece, we should give G01. Okay, so G01, X10, Z0. Then from here to here also G01. Again G01, X50, Z minus 60. G01 I didn't write because it is understood. It is in the memory of machine. So X50, Z minus 60. From here to this point, it is a circular interpolation. It is in counterclockwise direction. So we should use G03. G03, X70, Z minus 70, R10. So G03, X70, Z minus 70, R10. After that again G01. Again I write G01. G01, X70, Z minus 120. Okay. Then again G01, X100, Z minus 120. X100 minus. Again X100, Z minus 160. Again X100, Z minus 160. It goes till point. After that we have, so the turning cycle is finished. Then we have to relieve it outside. So X101, X101 value. Okay, so it comes out here. And then we in this problem I have introduced one more cycle called as finishing cycle. This is also turning cycle. If you use G71, it is called rough turning cycle. Material is removed more. If you use G70, it is called finishing turning cycle. Material is removed very little for minute operations to make a good surface finish. Okay, so again I am repeating this. After rough turning operation, I give again G70, same block number, same starts from block number 600, ends in block number 1100. So G70, P600, Q1100. This is finishing cycle. After this is done, again I will tell go to this X101, same like this. After finishing this finishing cycle, go to 101. After that, just stop the spindle, stop the coolant and everything, and go to home point and end program. Okay, so this is all about this program. So this is similar to the step turning operation. Here only change is about introducing the linear cut. Even though it is a tapper, we use G01 only. It's not having much difference, but one extra difference is here we have used the radial cut G03 in between. Okay, and then we can also use a finishing cycle. After finishing the rough turning cycle, we can use a finishing turning cycle with the help of the command called G70 with the same starting block number, ending block number, same like P600, Q1100, P600, Q1100, and then bring the cutting tool little away from work surface, that is X101. Then stop the spindle, stop the coolant, and then tell go to home point, and finally end the program. Okay, so this is how we do tapper turning operations. and fillet operations in turning machine. Okay, and in next class, in the next session, we will see how to make drilling operations in lathe machines. This is a simple drilling, and I am combining the drilling with step turning operations. This we will see in the next sessions. Okay, thank you so much.